Hi, Assalamualaikum. My name is Muhammad Fiazim bin Noor Azhan. My matrix number is 01DEM21F1048. So today, I will present to you about end of chapter 7 segment display. So, I will show you. Introduction PIC 1CF877A. The PIC 1CF877A is a widely used 8-bit microcontroller renowned for versatility, featuring a robust set of peripherals, ample program, memory, and versatile I/O capabilities, making a cornerstone in the realm of embedded system and microcontroller application. Introduction 7-segment display. Interfacing 7-segment display is a fundamental aspect of hardware design, enabling the visual representation of numerical information in electronic systems. The process involves connecting the 7-segment display to a microcontroller is digital circuit, allowing precise control over each of a segment. Understanding the pin configuration of the 7-segment display is a crucial, distinguishing between common cathode and common anode setup. By establishing connection between the microcontroller and the display, you create a pathway for conveying numeric or alphanumeric data. Lastly, the programming logic play a pivotal role as a dictate which a segment activate or represent specific number or character. Multiplexing technique may be employed for efficiency, especially when dealing with multiple displays.
Assalamualaikum and hello everyone. My name is Muhammad Al-Aiman bin Muhammad Ali. My matric number is 01DEM21F1045. Today I will be present about problem statement. Interface microcontroller PIC 16F877A with 7 segment with 3 switch. Switch 1 is pressed, then it will increment the count on 7-segment display. Next, switch 2 is pressed, then it will decrement the count on 7-segment display. And last but not least, switch 3 is pressed, it will reset the count on 7-segment display.
Next is a flowchart. Firstly, start. Second, initialize I/O. When after initialize I/O, switch 1 will press and 7-segment display will show increment count. When switch 2 press, 7-segment display will show decrement count.
First is to define the port C as a display. Next, we define switch 1, 2 and 3 at port B pin, which is RB0, RB1 and RB2. Then we define the variable and list down the code for 0 to 9 display. Next, we write code for up counter function for increment the number. After that, we write code for down counter function to decrement the number. Subsequently, we write code for delay. Afterwards, for the main function, we set port C as output port by write equal to 0. Then we set port D, which is switch, as input pin by write equal to 1. Next, we set initial number for display as 0. In addition, we write code if switch 1 is pressed, delay and call up counter for increment the number. Then find code and send to port C. Furthermore, if switch 2 is pressed, delay and call up down counter for decrement the number. Then find code and send to port C. Last but not least, if switch 3 is pressed, delay and reset the number to 0 and also find the code and send to port C.
Assalamualaikum warahmatullahi wabarakatuh. My name is Azhan Azizi Barazali. My matric number is 010F1066. Today I want to talk about circuit-based my design. First of all, the component what I use is capacitor, crystal, switch, ground, power, resistor, 7 segment, and switch button. First, number 13 and 14 connect to crystal and connect to capacitor C1 and C2 and connect to ground. Number 1 connect to resistor and power and switch button and ground. Number 15, 16, 17, 18, 23, 23, 24, 25, 26 connect to resistor and connect to 7 segment and connect to power. Number 19 and 20 and 21 connect to resistor and power and connect to switch button and connect to ground. Okay, now let's start the simulation. I start the simulation and it's on. Now I press the switch button. Increment is, and I press button decrement. And the last button is reset.
In the nutshell, successfully interfacing a 7-segment display using microstrip programming software and designing the corresponding Proteus simulation provides a hands-on learning experience in microcontroller-based hardware development and simulation. And that's all from us. Thank you.